Right, I'm David McNeat, and I haven't got lots of figures of profit and so forth because we're not at that stage yet. Well, I can say that investment at this stage is going to turn out to be very profitable. Let me explain where we are. The question is, where do trees come from? The answer is out of thin air. People think trees grow from the ground, but they don't. If they did that, there'd be a big hole under the tree, but there isn't, there's just more tree, okay? All the carbon in the cellulose, hemicellulose, and all the things that make up the tree come from carbon dioxide in the atmosphere. Carbon dioxide plus water plus energy from sunlight through natural processes equals wood, which equals fuel. We can synthesize fuel from carbon dioxide and water. We use energy, which may come from sunlight, and we plan to do it through a microwave plasma process. And that equals diesel, and that equals fuel. You can use the Fischer-Tropsch process to make liquid fuel, liquid hydrocarbon fuel from biomass, which is natural gas, coal. That used to be biomass, but is now being compressed and so forth. Carbon monoxide plus hydrogen. I should have CH there rather than CN, which is rather poisonous, plus H2O. CH should stand for long chain molecules of hydrocarbons. The general formula is CNH2N plus 2. So ethane is C2H6, and cetane, decane is C10H22, and so forth. Fischer-Tropsch process is actually used to make fuels. It's carried out in a plant the size of a small oil refinery under heat and pressure in the presence of a catalyst. It's an exothermic process, which means it doesn't cost much to run. The oil companies use it to turn gaseous hydrocarbons like methane into liquid hydrocarbons because they're much easier to store and transport. And they use it all the time to do that. In fact, there's something like 22 patent disputes in the European Patent Office between Shell and Exxon who won them all, I'm afraid. But CO is obtained by coking or partial combustion of methane, and CO plus H is called synthesis gas or syngas. It's got a nice name to it already, so it exists and has existed for lots and lots of years. Carbon monoxide can be obtained from carbon dioxide by a process just like Fischer-Tropsch, done in the same way, the same thing. We can make liquid hydrocarbons like diesel and jet aircraft fuels from carbon dioxide and water using Fischer-Tropsch. We need air, water and energy, and a large high capital cost plant that you don't want to run on a start-stop basis. And currently nobody wants to invest in this. But we believe we can make liquid hydrocarbon fuels from carbon dioxide and water in a small microwave plasma reactor. Inventure Fuels has already a fully funded research program starting the 1st of next month at local John Moores University, and that's going to deliver this within 1 year. We can already use microwave plasma, in fact there's a stand out there, Biofuels Wales Limited, to turn biomass into liquid fuels. So starting from carbon dioxide should be a lot easier than starting from biomass. Now that means we have a way of storing electrical energy by turning it into hydrocarbon fuel. We don't know what the cost is yet because we haven't done it, but it shouldn't be any more than the cost of 20 kilowatt hours of electricity per litre. At 10 US cents a kilowatt hour, that's $2 a litre. At 5 US cents, that's $1 a litre. If I'm over pessimistic, it could be less than that. Now, if you try and figure out the cost of fuel with oil at $100 a barrel, if you just had a barrel of oil and waved a magic wand over it and turned it all into diesel, it'd work out at 70 cents a litre, believe it or not. I don't know how they sell it at the price. So if we're fully funded, why do we want more money? Well, we need to develop carbon capture for our microwave plasma reactor. Carbon capture has been pioneered in America and Canada. In America, they use absorption in plastic sheets, and in Canada they use a chemical thing based on paper chemistry, and they can get carbon dioxide out of the atmosphere for somewhere between $10 and $25 a ton. What I want to do is to use cryogenics. We already get oxygen, nitrogen, argon out of the atmosphere by cooling it down until they separate, until they become liquid, and then we separate them out. Carbon dioxide also gets captured in this way at about minus 70, minus 80 degrees centigrade, but they throw it away because there's so little of it that it's much easier, much cheaper to get carbon dioxide from some other place. So, but we don't need any new technology, we just need cryogenics. There's not much carbon dioxide in the atmosphere, it's about 390 parts per million, but it's surprising how little engineering is needed to get at it. I've got a picture of, which I drew myself, it's not brilliant, but it's a picture of a wind turbine with an inset into it, an air intake needed to capture CO2. So there's a standard wind turbine, 60 meters across, and we need a square opening of about 22 meters across to capture the energy, to capture the carbon dioxide that wind turbine could turn into fuel. And we need to make a small-scale refrigeration plant and use it to evaluate the cost of cryogenic carbon dioxide capture and the feasibility of a plant that would match the output of a wind turbine. And our funding for the microwave plasma stuff that we're doing now, I think would be about the same as required for making the cryogenic plant, and we think we could do that with all of the technology input that would be required to handle the output from a 3 megawatt turbine, and would be about £200,000 to design that on the basis of our experimentation. I haven't got all the nice figures because we're nowhere near being able to figure them out. But the fuel output from a 3 megawatt turbine could be as much as 36,000 litres a day. So that is basically what we're aiming for. People do not want all the time the power from wind turbines. We can soak that up, and this would be a very good introduction to the whole concept of generating fuel out of thin air.
Thank you very much. I'm not sure I must confess, I'm not sure that I totally followed that. I mean, it sounded like quite a big element of it was where to get the carbon dioxide from.
Look, we know where to get it from.
Well, it just strikes me that one place where it's already quite concentrated is when they're actually planning to kind of get it all into one place and then actually lock it away and capture it. And I just thought maybe, again, turning to Philip, who's looking at carbon capture and storage, whether you might kick off on responding to this presentation, Philip.
Yeah, I guess this comes into the general context of air capture of CO2 to make fuels. Apart from stranded island communities, I cannot see the day when we'll have so much electricity that we can use it for such a purpose.
The long-term plan is to stop digging up fossil fuels because they put too much carbon dioxide into the air. Sure. If we could generate fuels out of the carbon dioxide already in the air, it would be totally recycled. Now, if we can, this is just a way to get into the whole concept of making fuels out of carbon dioxide captured in the atmosphere. We know it's all possible, it's all been done. What I'm aiming at in the long term is to say we're going to stop digging up fossil fuels altogether. If we used sunlight, we would need 150,000 square kilometers of solar collector to avoid having to dig up any more fossil fuel, which is doable.
Yeah, well, I can see all that, but still, what I come back to is the thermodynamics of the situation, which is that with any fuel, to get it to something you use, you've got to put it through a cycle where you'll have a cycle efficiency of no more than 50%, whether it's a combined cycle gas turbine or whatever. If it's a car, it's 25% more likely, a jet engine even less. When to make electricity, you've already thrown away those things in a conventional power cycle. To me, if you've got the prince of energy vectors, which is the electricity, why would you use it to produce something where, when you put it into an engine, you're going to throw half of it away? I just don't understand.
Look, Iceland generates 25% of its power from geothermal energy, and the other 75% from hydroelectric sources. So that's 100%. However, Iceland still imports 15,000 barrels of oil and oil products a day. Now, with 2 megawatts of more, they could actually avoid having to, they could make their own, basically.
Sure, okay, I get that. But Iceland is a very peculiar place, and it's a small dot on the map in the globe. And maybe something like this would have a place in Iceland, but the reality, as I see it, of the world we live in, is that we're not short of things to do with electricity, except in island communities. So the day may come when we want to make fuels in this way, because maybe 50 or 100 years out we'll run out of hydrocarbon fuels to run aeroplanes with, but I feel it's a long way off.
Yes, it is a long way off, and this is a start. And because it's very difficult to get people to invest in the big stuff, I really want to make a start with the small stuff. You can use power from wind turbines that you can't store when you don't want it.
Okay, I'll buy that, but in the short term, I would go to the back end of a biomass power station or even a fossil power station and save yourself all the agony of the air capture of the CO2 and get it for free.
It's less expensive actually to get it out of the atmosphere than it is to get it from a power station. And the thing is, you can generate it, you can capture it from the atmosphere wherever you're generating your power. So if you've got the Sahara Desert covered in solar collectors, you could just collect the air from the Sahara Desert and get the carbon dioxide out of it, and incidentally enough water to react with it. And all you have to do is transport the fuel away. I know, but...
Okay, let's end this one. I think Philip looks totally unconvinced, if I may say. Michael?
Yeah, we did actually do some work with Biofuels Wales, who also did some work with Liverpool University on the microwave plasma. It is really worth looking at their stall. It's the most unimpressive stall you can see. I think they've got a poster up, but they've also got some really interesting jars of product where they've taken the byproduct from grain harvesting and turned it into a sugar-based solution that you can use for all sorts of things, purely using microwave plasma technology. We did some work with them on taking that potential to investors, and I think it's an interesting thing from your point of view. There has been interest, and I think a couple of investors have made offers. Secondly, the whole process has really demonstrated, and I think this is the problem you'll have, the investment community have got the attention span of fleas, and they want the most defined, precise proposition. This is what the guys from Biofuel Wales discovered very quickly. They had this great technology that took what looked like a waste product, or miscanthus or elephant grass, and turned it into a sugar-based solution that you could use for all sorts of things. You'd think that'd be enough, but no. What exactly are you going to use it for? Which exact markets are you going to be in? What's the exact price of something? And I think the difficulty with your presentation is there's an idea there, I can see it. It's far too ambiguous and vague. And if you talk to the guys on Biofuels Wales, they've been around the investment community with a plasma-based technology and honed it down to a very, very precise proposition. And that's the basis that people will come in. That people will not come in on, I can have a huge big picture vision. they'll come in on a very precise application in a very specific industry.
We may be talking about different people because they've already come in with me. I've got adequate funding for the conversion of carbon dioxide into fuel.
I'm assuming maybe there isn't a burning patent question in this, or if there is, Tommy?
I know he's a patent agent, so I hope he's got that covered. But
I have indeed.
I did want to know, what's your arrangement with the university though? Is going to be a sharing of that?
No, we own the whole thing. We own anything that they produce.
Can I just say one other thing? There is one fund in London, and I can't remember the name, and it will come back to me, who specialise in university spin-outs of technology. And just as a wider point, they have a very interesting business model. Yeah, I don't think it's that, but let me keep going. So they have a fund, all they do is back university spin-outs in the green space, but more widely. What's interesting about them is they won't invest more than £300,000 or £400,000 in any given application, and they value every single business at £700,000, whatever your business is. If they decide to invest in it, they don't waste time arguing with you about the valuation. They say everything we invest, £700,000 is the value of your business, and we'll give you 300 to 400 for that percentage of the business. And that's the deal. And they're a very interesting bunch because they do back things that spin out. They only back things that spin out of universities. And I will think of the name at some point, probably on the way home.
I've just got one short question. I don't know enough about the technology, but we had a company which presented at a sort of Dragon's Den style panel that we did in August in London, and that company was called Air Fuel Synthesis. So I don't know if you're familiar with them.
Yeah.
I don't think you're talking about the same technology,
No,
but just as a comment really, the investors on our panel in London, who include people like BP Ventures, GM Ventures, and a couple of other sort of venture capitalists, they all said, well, why aren't you going to a point source of carbon, which I think is the same point that everyone else has been making. And as an investor, they said, well, look, there's a lot of carbon out there that needs to be turned into something. Let's do that first. And air fuel synthesis, obviously, it says it in the name, I think, trying to do it with air, but have now focused their business model on the carbon point sources, as it were.
Okay.
Thank you very much.